Hello everyone. Um, Today we will see train test split. Train test split using Scikit-Learn, and we will say we consider data set an array. Inside this array, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the numbers that is inside this array, and I will use Scikit-Learn to split into train set and a test set. First of all, I have to use necessary packages. For it's a from Scikit-Learn dot model selection import train test split. So we imported the function, and now we will use that function as it is a train test split. So basically we will have two sets, a train set, say full train set. I named it as a full train set. For test set, I named it a final test set. I named it as a full train set and a final test set. You can name anything you want. So I will use this function, train test split. Inside this function, the very first thing, I will insert this array named data. Okay, I wanted to apply 80-20 split. For that, test size, I give 0.20. That means 20% inside the test set. Then automatically it will allocate 80% to the train set. So major important thing, random state. Random state 42. What is random state and what is 42? Basically, random state is performing like a seed. You will find a lot of time seed when dealing with random numbers. If you don't understand seed, basically what is seed or what is random state basically perform at the same level. In the package called Scikit-Learn, it is very much known as a random state, quite a different. So random state is basically like it will generate random numbers, and those random numbers will compare to indexes, and this indexes will definitely have to go through shuffle. Say in this function you can write shuffle. By default this shuffle is true, so it is no need to write it again. But if you don't want to shuffle, then you can turn it to false. Then it will be no shuffle, because every time you run the command, it will generate the same items inside train set and a test set every time. If you turn off this shuffle, then you will find every time different sets. So that is the reason why we're dealing with random state. And why 42, not 41, 43 or 10? Basically 42 is a global one. Everyone use that. Why everyone use that? Because there is a valid reasons. One reason is if you use random state 0 or random state 1 against random state 42, we will see that random state 42 outperforms against random state 1 or 0. So in contrast of the performance, random state 42 outperforms against the other. That is the valid reason so why we use that. Another important reason is, say there is a two researcher, A and B. A wants to compare his research with B. So certain things needs to common between A and B, such as this random state 42. And there is the same reason why everyone people uses the train test split 80/20, because further at the later time there needs to done benchmark comparison, any kind of comparison between them. So certain things needs to common. If it is not same for the both researcher, then there will be no way to compare between them. I know 85 and 15% split can give you better results, but at the later your research cannot be compared with other research, so that will be a lacking in your study. So that is why if you see in research fields, maximum time of the time you will see this 80-20% split. Okay, our function is defined. What we already done, we named two sets and we call the function. Inside this function we inserted the data and we called it 80-20% based on the test set size, and random state for reproducibility for identifiable random numbers or identifiable sets. Every time you run the command we use 42, and the shuffle by default true. If you do not want to write it, you don't need to do that. So I will find from here a full, after running this command, full train set, and the final test set. Okay, from okay, what is the numbers? 6 1 8 3 10 5 4 7, and in the test set I will found this 9 and 2. Now there is a question how we find these results. See, by the blessing of this random state, we will find every time you run the command the same numbers inside train set, the same numbers in the test set. Basically what random state is done, it generates an index. Suppose if you want to write the indexes for this index, we will find 0 1 2 3 4 5 6 7 8 9. This is the index for these numbers, and using this random state scikit-learn generates new indexes 8 1 5 0 7 2 9 4 3 6. This is our new index, and this new index is shuffled also using the shuffle property. It is inside this scikit-learn internally performs like this. So if you see our index 8, if you compare this one with this one, the index 8 got 9, the index 1 got 2, index 5 got 6, index 0 got 1, index 7 got 8, index 2 got 3, index 9 got 10, index 4 got 5, index 3 got 4, and index 6 got 7. Now you can split it like from that part or from the very beginning. Scikit-learn start from the very beginning for the test set, and the scikit-learn speak like this way, and this part inside test set, and the remaining this part will inside train set. That is why we found this one. And every time you run the command by the blessing of this property random state, you will always find this full train set and this final test set. Thank you very much for this part of the class. If you missed that part, we arrange these arrays, and after that arranges, we split from the very beginning and we take it into a test set, and the remaining part will be inside our train set. So thank you very much for this part of the class.